Okay, we're beginning our fourth unit, which is extending the number system, and we're going to be looking at the first standard, which says to rewrite expressions involving radicals and rational exponents using properties of exponents. Alright, so remember, expressions are just math problems that involve numbers and letters and different operations. Radicals are square roots, cube roots, fourth roots, fifth roots. But you're going to have this symbol right here. This is your radical symbol. Exponents are powers that tell you how many times to multiply the base. And they're the small number up top. Rational numbers are numbers that can be expressed as a fraction. So we're going to be dealing with fractions. So good thing we've been looking at those all year. Alright, and this is your rule that you're going to go. If you have a radical, this right here is your radical because it's your radical sign. Whatever root you're taking is going to be here. If it doesn't have a number, it's understood to be 2. Otherwise, it will have an understood 2. Your base is your big number, what you're going to be taking the square root or the cube root of, and then you may have an exponent. So if you want to rewrite that as exponential expression, you're going to have your base, which is your big number under your radical. Your exponent will be your numerator, and your root will be your denominator. So that takes care of the rational part. Your rational, meaning that you're going to have a fractional exponent. So what we want to do is take this rule, or this understanding here that we have right here, and we want to write the radical expression as an exponential expression with rational exponents. So that means we're going to have an exponent, and we're going to have rational numbers that are exponents. That means they're going to be fractions. So we've got our radical. The root is 3. That's my root. This is my big number. It's my base. And then the power is going to be my exponent. So if I want to say what that equals the base, which in this case is x. And my rational exponent is going to be, well, the exponent is 7, and the root is 3. So the cube root of x to the 7th power is equal or equivalent to x to the 7 over 3 power. We want to do the same thing here. So I want to change this radical expression to an exponential expression. So my base in this case is x. My exponent is 3, so that will be my numerator. And my root is 4. So the fourth root of x to the 3rd power is equivalent to x to the 3/4 power. Here's my last example of writing an exponential function out of a radical expression. So again, my base is x. My exponent is 4. And my root is an understood 2. That's, if I read that, I would say square root. So I could say the square root of x to the 4th power is equivalent to x to the 4 over 2 power, which could be reduced or simplified to be x to the 2nd power. Now let's look and go the opposite way. If we start out with an exponential expression, we can also write that as a radical expression. So I want to do the same thing. I know here I'm going to have a radical if I want to write a radical expression. The root is 7 because it's my denominator, and that's where roots go. My base is c. And my exponent is 2. So c to the 2/7 power is equivalent to the 7th root of c to the 2nd power. Here's another example. If I want to write this exponential expression as a radical expression, my root is going to be the 5th root because it's my denominator. Call my radical. My base is c, and my exponent is 3. So c to the 3/5 power is equivalent to the 5th root of c to the 3rd power. In my last example for this, if I want to change c to the 5 over 2 power to a radical expression, my root is square root, so let's just do square root. Remember, square roots don't have to have the indicated root, it's understood. My base is c, and my power is 5. So c to the 5 over 2 power is equivalent to the square root of c to the 5th power. That is my radical expression. We're going to practice this some more in class tomorrow, so hopefully you'll be prepared.